Hello and welcome to lesson 1.6. Now lesson 1.6 talks about describing pairs of angles. Now we're not going to start with the exploration first. So we're actually going to start on page 29 of your student journal. So while you're there, please make sure you write down where the problem numbers are going to go. Problem 1 and 2 are going to go in that space provided at the top of page 29. 3 here at the bottom. Now, I strongly suggest that you guys grab a highlighter because there's going to be a lot of vocabulary that you guys will need to know for the rest of this book. It will be coming up a lot of times. All right, so the first concept that I want to talk to you guys about is about the difference between complementary and supplementary angles because they're different. Now, complementary angles are two positive angles whose measures have the sum of 90 degrees. So they have to add up to 90 degrees. Now, each angle is said to be the complement of the other. Okay, so if the angles add up to 90, they're complements of each other. Now, sometimes they're going to be adjacent, like you see right here, and we're going to talk about that in a little bit. Sometimes they're going to be completely disconnected, where they don't share the same vertice. Here, vertice B, vertice A. Here, both angles have the same vertice. So these are called complementary angles. On the right-hand side, you have the supplementary angles. And it's the same idea. The only difference is that the sum, in this case, is 180 degrees. And each angle is called the supplement of the other. So you need to know the difference between the complement and the supplement because they mean two different things. And similarly, like on this one, sometimes the vertices are not going to be the same. Like this one and this one, they have a different vertice. But if you were to add the measurement of those angles, they add up to 180 degrees, making them supplementary. Now, sometimes they're going to be connected, sharing the same vertice. Now, when this happens and the angles are not only supplementary but also adjacent, we call these two angles a linear pair. Why? Because when you put them together and they share the same line right here, they're said to be called a linear pair. They make a line. Makes sense. All right, please turn to page 30 really quickly. Now, what we were just talking about is adjacent angles. Now, both complementary and complementary angles and supplementary angles can be adjacent or non-adjacent. Adjacent just means that there are two angles that share a common vertex and a common side, but have no common interior points. For example, here 5 and 6, they happen to be adjacent because they share the same common side. Here, they're not adjacent. They do not have any common vertex or common side. Now, we already talked about linear pairs. Two adjacent angles are called linear pairs when their non-common sides are opposite rays. A little confusing. Pretty much saying that you have the common vertice and the non-common side. Like this is the common side. These are the non-common sides. That means that they have to be opposite rays. One has to go in one direction. The other one has to bounce back the other direction. Now, here's the fun part. Vertical angles. Two angles are vertical angles when their sides form two pairs of opposite rays. Now, vertical angles, this one and this one, 4 and 5, and this one, 3 and 6 are vertical angles. And guess what? They're the same measurement. So angle 3 and angle 6, they're congruent. Angle 4 and angle 5, they're also congruent. Now, the only way that they're all going to be congruent is if they're all right angles. But we're going to get to vertical angles later on. And by the way, problem 4 goes here, problem 5 goes there. So let's go back to the exploration on page 27. All right, so you got that cool star right there. Now, what I like to do, and sometimes I probably waste a little bit of time because I solve for everything before I even look at the questions. And then I look at the questions and notice that I already have all the answers. So let's do that. I'm going to zoom into my little star on page 27, and I want to solve for every angle that I possibly see there. Okay? All right, so the first one that I'm going to focus on, which is the easiest, is the vertical angle. Okay? Because the angle that is right across angle Y happens to be 108. So guess what? Y measures 108. The next angle I want to find out is angle X. Now, if you notice X and Y, when you combine them together, you form a straight line. So because it forms a straight line, we say that they are supplementary. So in order to figure out what angle X is, I have to subtract 180 minus 108, because remember, the sum of these two angles, in order for it to make a straight line, they have to add up to 180 degrees. So 180 minus 108, so 180 minus 108, that's going to give me 72. So guess what? X is also 72. And because Z is vertical to that, Z is also 72. So now I notice a little bit of space here, but let's take a look at something that, that I forgot to read in the example. It says the 5-pointed star has a regular pentagon. Okay, so it's a regular pentagon. What does that mean? A regular pentagon means that all the angles in the interior are also the same. So if that angle right there is 108, guess what? So is this one. Which means that W is supplementary to that one, which means that that one right there, W, has to be also 72. Now to find V, well, one of the things that we need to know and remember, you probably do remember this from middle school, is that the sum of the angles in a triangle have to add up to 180 degrees. Okay, so if I were to add 72 and 72 and subtract that from 180, then I get the measurement of angle V. So 72 plus 72 is 144. So 180 minus 144 is going to be 36. So V is 36. So now I have all the information to go back and answer my questions. All right, so first question is, what do you notice about the following pairs, angle pairs? X and Y. Well, they're adjacent to each other. They form a line. Therefore, they must be a linear pair. Okay, so because they are a linear pair, they're obviously going to be supplementary. Now, Y and Z, they're doing the same thing. So guess what? They are also a linear pair because they're supplementary. Now, X and Z, they're the same. They're vertical angles. And then you can proceed to answering the ones here at the bottom by simply just looking at the diagram and answering what they are. So X is 72, Y is 108, Z is 72, W is 72, and V, we calculated that to be 36 degrees. Let's go on to the next exploration, which is on page 28. All right, so pretty much the same idea, but we have in this case something a little different. All right, so here we have this little box. What does the little box mean? It means that it is a right angle. All right angles are 90 degrees. So that means that This is also a right angle because it's vertical. And since these two form a straight line, that means that the sum of this angle and this angle has to be 180. So if I subtract 180 minus 90, this is going to be 90. So that's 90, and guess what? This has to be 90 as well. Okay, there's a lot of stuff going on in here. Okay, now this is indeed a square. So we do know that whatever angle A and B are, they have to add up to 90 degrees. So A and B happen to be complementary. Okay, C and D happen to be supplementary. And C and E happen to be vertical. Okay? All right. Oh, I have a joke for you guys. How do angles flirt? They give each other compliments. Get it? Yeah, I know. By the way, guys, I will be telling you guys the lamest math jokes you can ever think of. So get used to them. Oh, I have another one. How do supplements get really, really buff? Well, they take supplements. Haha. I really need to get me those drums. All right. So C, D, and E. C, we already said it was going to be 90. D was going to be 90. And E was also going to be 90. All right, guys. We are ready for our examples. So let's start with example 1. All right. In the figure, name a pair of complementary and supplementary in a pair of adjacent angles. So remember, in order for these to be complementary, they have to add up to 90 degrees. So you have to look and see which one of these add up to 90 degrees. So let's see. Oh, sorry, a little bit. All right, so I'm thinking, what is the sum of 37 and 53? Ah, it's 90 degrees. So that angle and that angle, they add up to 90 degrees, therefore they're complementary. So all I got to do is list them. Now, we already know how to name angles. You can name them different ways. So I'm going to name angle CACAB and angle RST-TSR. I can even call it angle S. It's the same thing. RST. These happen to be complementary. Now for the supplementary angles, well, let's look. 127 plus 53 equals 180. So this one and this one, they add up to 180. So angle CAD and angle RST are supplementary. And I do apologize because my handwriting is really bad. Doing the best I can. And adjacent angles. Now, adjacent angles, they have to have a common vertex. And they have to have a common side. Voila, right here. So those two angles, CAB and angle CAD, those two happen to be adjacent. All right, so that's example 1. Let's look at example 2. Example 2 is easy. All right, example 2. Angle 1 is a complement of 2. The measure of angle 1 is 62. So find the measure of angle 2. All right, so here's the thing. By the word complement, it means that their sum is 90 degrees. So that means that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And they tell me the measure of angle 1 is equal to 62. I'm going to substitute that. 62 plus the measure of angle 2 equals 90. So to solve for that, you have to subtract 62 from both sides. So the measure of angle 2 is 90 minus 62, which is 28. Okay, and A is done. Now let's look at B. Okay, now B is the same idea. The only difference is that instead of them adding to 90 degrees, they're going to add to 180 degrees. So the measure of angle 3 plus the measure of angle 4 equals 180. Why? Because it's a supplement. The measure of angle 4 is 47. So we got to subtract, guys. Subtract 47. And by the way, guys, I use the word guys a lot. It means for the girls too. So girls, don't feel left out. When I say guys, I mean everybody. I just forget to say girls too. Call you guys folks. How's that? All right, so the measure of angle 3. And that is example 2. All right, let's look at example 3. All right. Now, I've never played soccer, and I've actually never seen this, but apparently it's something that they use. It says, when viewed from the side, the frame of the ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and ECD. Now, the key word here is supplementary. That means that their sum is 180. So I got to add this one and equal it to 180, solve for x, and then go back and plug it in on both. So let's do one thing at a time. 4x plus 8 plus x plus 2 equals 180. Combine the like terms, 4x plus x. That's 5x plus 8 plus 2, that's 10. And solve for x, a two-step equation. Subtract 10. And you get 170 equal to 5x, so you divide both sides by 5. And x is equal to, whoops, I'm going to go through mechanical pencils a lot, 34. But they're asking me for the measurements of both angles. So I got to go back and figure out what that's going to be. Okay, so the measure of angle BCE is equal to BCE. It's 4x plus 8. So what I'm going to do is substitute that value in that place. Calculate that. And that's going to give me 144. So that's the measure of BCE. Now all I got to do is go back and put it in the other one. The measure of ECD is x plus 2. Oh, that's even easier because x is 34. 34 plus 2, that's 36. So that's going to be the measure of ECD, 36. And that is example 3. All right, example 4. Identify all linear pairs and all vertical angles. So remember, linear pairs, they have to form a straight line. And we're talking about a pair, not 3, not 4, 2 angles that combine to make a line. So in this case, the only diagram that does that is angle 1 and 4. So angle 1 and angle 4, they form a straight line. Now, Mr. Osuna, doesn't angle 1, 2, and 3 do that the same thing? Yes, they do. But we're talking about a pair, not a trio, a pair. So angle 1 and angle 4 happen to be the linear pair. Vertical angles, now a lot of you guys are probably saying 2 and 4 because they're across from each other. Nope, they are across from each other, but if you look at it, they're not the same size. The only ones that are possible are 1 and 5. So angle 1 and angle 5, those happen to be vertical. Later on, guys, we're going to prove why they're congruent. But for right now, they're just vertical. All right. Last one. Last one's going to be probably a little confusing because there's a lot of wording to it and you have to interpret what it says. It says two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. Now think about this. If you were to make a diagram out of this, you have two angles. Okay? This one, you don't know how much it is, but they do tell you that the measure of one angle is 5 times the measure of the other. Well, what's 5 times the measure of x? Well, 5x. So 5x. Give me 1 second. My mechanical pencil's running out. Oh, there you go. 5x. So the sum of both of them is 180. So 5x plus 1x equals 180. So that is 6x equals 180 divided by 6. X is equal to 30 degrees. Find the measure of each angle. Well, we already know this one. That one's 30 degrees. And because this one is supplementary to this one and 5 times that, that's going to be 150 degrees. So we have our angles, 30 and 150. All right, and that is example number 5. Please make sure you guys complete your extra practice, and we will see you later.